Hey everyone, and welcome to Content Security Policy Zero to Hero. The goal of this talk is to cover everything you need to know to deploy a secure policy within your organization. This talk is split into three different parts. Part one, we're going to cover the theory. What is CSP? What is it trying to prevent? Part two is implementation, so how to build a policy, how to roll it out within an organization, and some considerations. And part three will be kind of a grab bag of extra features, tools, some useful URLs, and resources. Who am I? I'm Stuart. I'm founder of Casper. Casper is a company that helps deploy CSP. We've been around for 4 years, and during that time, we've helped many thousands of websites deploy secure policies. Previously, I was a developer, pen tester, red team, security engineer at a variety of different companies. And in my free time, I'm a competitive CTF player, and I also do CTF write-ups, and I post them on YouTube. So part one, theory. What is CSP? Well, I think to understand CSP, you have to understand what it's trying to prevent, and it's trying to prevent cross-site scripting. And so cross-site scripting, there's many different definitions and types, but I like to think of it as just malicious injection of JavaScript into a web page. And so here's a little example app of what that might look like. You can imagine we have a Twitter-like app, and on the left, you can type something like, I am learning so much about CSP. You can tweet it. And when you hit that tweet button, we know that the browser is going to send a request to the server. The server is going to save that tweet into its database. And then the next time you view that page, the web server is going to return some HTML that kind of looks like this. You have a div class tweet. This is HTML. You have div class tweet. You have a paragraph tag. You have your content. And your browser is going to take this and it's going to render it. And now you can see the tweets. If you were evil and this Twitter-like application didn't have XSS protections, you might be able to do something like this, where instead of just typing in text, you could try to inject some HTML that'll execute some JavaScript. So we could type in script, source is equal to evil.com/malicious.js, close script, nothing to see here. And so this tweet's going to be sent to the web server. It's going to be saved in the database. And the next time a user tries to view this tweet, the browser is going to get some HTML that looks like this. Div class tweet, paragraph tag, script tag, source is equal to evil.com/malicious.js, close script. And so when the browser sees this, it's going to download that script. It's going to execute whatever is here. And then we get the rest of the tweet, nothing to see here. So obviously this is pretty bad. There is a lot of stuff you can do with an XSS. Once you have JavaScript execution within their web session, you can do anything that user can do. So you can start reading private messages, you could tweet propaganda. If there's credit cards, you could try skimming them. So as a user types into a form, you can just take those and post the value somewhere else. You could pretend to do a logout. So you say like, hey, your session has expired. Please retype in your username password, and then you can skim those too. And that's just for a Twitter-like app. There's plenty of websites on the internet, and some of them are much more serious, such as financial apps, medical apps, infrastructure apps. And you can steal funds, you could leak medical records, take down infrastructure. It's very serious. And so because it was so serious, the browser vendors got together and they implemented this protection called cross-site scripting to help prevent this. So what is cross-site scripting? What is content security policy? It is a tool to help prevent XSS. The way CSP prevents XSS is it tells the browser what the allowed resources and origins are for different content types. So it was a little bit strange in the previous example where we were loading JavaScript from evil.com. Our application should never be loading JavaScript from evil.com. And so with CSP, you can tell the browsers like, hey, like the allowed sources of JavaScript are these origins, and that's it. Like don't be loading JavaScript from evil.com or any other shady website. And this is what those policies look like. So this is an example of CSP. On the left here, these dark blue things are called directives, and everything else is called sources. So one of the directives is script source. This is where you're allowed to load valid JavaScript from. And so we can see we have a script source of self, js.stripe.com, googleanalytics.com, and googletagmanager.com. So that means when the browser encounters a script tag, it is going to check and make sure that the script that it's loading belongs to one of these origins or self. And we'll talk about what self means in a second. And you can do these for all the different content types. It's not just JavaScript. We also have styles. So this is CSS. We have images. We have frames. We have fonts. You can specify where all these different contents are allowed to be loaded from. And this is where the word content security policy comes from, because it is a policy of where you're allowed to load different contents. So how do we deliver content security policy? It's delivered through the HTTP headers. So if you remember your browser, when it communicates to the server, it's communicating using hypertext transfer protocol. And this is what it looks like. We're going to use a verb. So we're going to ask to get index.html from app.com. we're using HTTP 1.1, just the version. The user agent is our browser, and there's a bunch of other HTTP headers. So the browser makes this request to the web server, and then the server responds with another HTTP response, and is HTTP 1.1, so the version, status code 200 OK. The content type is HTML. The content length is 4567. This is also where they could set cookies if they were setting cookies on a web server, and this is where they would install the CSP. So we can see it as a HTTP header. It says content security policy, default source none, script source none, or self, and then the HTML. So the content security policy here is applied to this HTML document. To actually install it, there's many different ways. Just anywhere you can install a HTTP header. For example, this is what Node.js might look like if you're using some middleware. So you can do app.use, and then this is just function middleware, and you can just set the header. And so this will be returned on every call, on every HTTP response. All right, so diving into what a policy is and what goes into a policy, like I said, there are both directives and sources. And so these are the common directives. I'm not gonna read over all this, I'm just gonna skim through it. A lot of it is kind of common sense. So script source is probably the most important one. This is where you're allowed to load JavaScript from. And so an example might be self, I'll be talking about that in a second, or maybe cdnwebsite.com/jQuery.js. So that means we are allowed to load this JavaScript from here. Another very common and security sensitive one is object source. This is where you're allowed to execute objects from. You can think of like Flash or Shockwave. For the most part, this will be none, which means most websites aren't using Flash or Shockwave, hopefully. And so you can just say, don't load any Flash or any of these objects. Style source, this is where you load CSS from. So you might say load CSS from, again, self. We'll talk about that in a second. Some CDN. There's fonts. There's images. There's connect source. Connect source is your APIs, your API calls. So this is Ajax and Fetch. This is also WebSockets and event source. And there's some other navigators and stuff like that. But basically, if you have like a single page application, like if you're building React or Angular or something, usually you have that JSON API that just is being called from JavaScript. Connect source is involved with where those API calls are allowed to be made to. There's media source. This is your audios and videos. Your base URI. This is another very security sensitive one. It's not used too commonly, but there's an HTML tag that you can use just called base and base href, and this specifies kind of the offset for local paths. Most websites don't use it, but if you do use it, you can restrict it, but most websites just say base URI none. And then last, there's also frame source and child source, and this is involved, so where you're allowed to load content from for within iframes. There are even more of these directives. I'm not going to cover all of them. I think these are just the common ones. And then there's some other security sensitive non-content directives, which I'll talk about a little bit later. But for the most part, when you're building a CSP, these are the different directives that you're going to specify all your content. So for all those directives, you're allowed to specify a bunch of different sources. The most common one is probably a host source. So you can have a full URL. So it would be like HTTPS. You're allowed to load, let's say, this JavaScript file, example.com/something.js. You can also just specify a host. So it could just be anything from example.com. You can also do a port, anything from example.com on the specific port. And you can also wildcard stuff. So anything that belongs to the subdomains of example.com. You can also specify a scheme. So anything over HTTPS. You sometimes see this on image source. So your policy might say you're allowed to load images from anywhere as long as it's HTTPS. We're going to be talking about these two a little bit later, more in depth, but you can also specify nonces, which is a way to allow inline JavaScript, and also hashes, which is another way to allow inline JavaScript and other resources. Cool. And then on the topic, there are also keyword sources. So self, as I mentioned, this is a very common keyword. It's used pretty much in every policy, and it says you're allowed to load resources from the origin that delivered the policy. So like if you have a website called app.com, and app.com/index.html returns a policy, the self would be the origin, which is just app.com. So you can say like maybe script source self, which means you're allowed to load any JavaScript from that same origin, which is usually what you want. None means don't allow anything. So this would be common for for object source. So if you don't have any flashes or any of those object types, you would just say none, and it means don't load any of those. And so if you can do none, obviously that's the most secure. There's another keyword source called unsafe inline, very commonly used, but it shouldn't be used. This is probably the worst thing you can do with your CSP policy. Basically, this negates all the protections, and we're going to talk about this a little bit more. But basically, this says you're allowed to have inline JavaScript. Yeah, it's not ideal. There's also unsafe eval. We'll talk about this one a little bit later, but CSP blocks the usage of eval, and this re-enables the usage of eval. There's also report sample, a very useful source. And it says whenever the browser generates a violation report, again, CSP is very complex. We're going to be talking about this stuff later. It'll include a sample of what was blocked, and then strict dynamic. Again, we'll talk about this later, just including this for the sake of continuity. It is a more advanced feature of CSP where you can build models that have trust propagation. And I'll talk about that later. Anyway, so that was a whirlwind tour of all the directives and sources, but hopefully this policy makes a little bit more sense. We can kind of go through it. We have all of these directives, we have all of these sources. So we had the script source like we talked about before. So if this was returned from app.com, we're allowed to load any script sources from self, so app.com, any JavaScript from Stripe, from Google Analytics. Specifically for this one, we can only load analytics.js from Google Analytics, and from this js.stripe.com/v3, we can load any files after this directory. And then also Google Tag Manager, again, anything after this directory. We have a base URI. We can see under style source, we allow unsafe inline. So if an attacker is able to find an XSS, they can inject arbitrary CSS. Depending on your security model, this may or may not be accessible. Object source is none. If you can do this, you should. Image source is self, but we allow image to be embedded through data. Sometimes some minifiers and website kind of just speed up websites. They'll put the data embedded directly in the HTML as a data tag, and that way you can load the images over a single page load instead of having to make a separate HTTP request for all of them. So you're saying this says you're allowed to load images through the data tag, and you're also then allowed to load any images over HTTPS. Frame source, like we talked about, so I can embed, this website can embed videos from YouTube, for example. Font source, they allow the loading of fonts from gstatic.com, so Google Fonts. Also, fonts can be directly embedded. And connect source, this is where you're allowed to make those AJAX calls, those HTTP requests through an API. If one of the directives is missing, CSP has a fallback mechanism called default source, and that means if there's some other content type that's missing, if a default source is specified, it'll fall back to this, and this says self. So you can load any content off the same origin. Cool. So one thing that was kind of glossed over, but very important, is how does specifying a script source prevent an inline cross-site scripting? And this is part of the frustrations and also what makes CSP secure. And that is that inline scripts and also evals, which we'll talk about later, but inline scripts are blocked. So that means you're not allowed to have any inline JavaScript. And so what that looks like can be seen here. So going back to that example we had earlier, we had that script source with the evil.com/malicious.js. If we imagine that this HTML is returned with the following policy, content security policy, script source self, the script source evil.com would be blocked, so that would not be allowed. But these two things down here would also be blocked. There's a button on click, and when you click it, it executes this JavaScript. This is just part of normal HTML. Unfortunately, CSP does not allow this. And also this script tag open, maybe you have like a Google tag manager down here script, or Google Analytics. This would be blocked because it is inline JavaScript. You are no longer allowed to have any inline JavaScript. And that's just because there's no way to differentiate between malicious inline JavaScript and allowed inline JavaScript. So you just have to move all of it. There are some protections, we'll talk about it in a second. Not protections, but ways to enable it through tokens and hashing, but that's a little bit later. The recommended way is just, if you can, remove all of that inline JavaScript and just put it into its own file. And so this is kind of what it looks like. We have the same page as earlier, except instead of having those inline handlers, we now moved everything into its own file called app.js, and we have, find that element. If it's this is just using a jQuery selector, select that element and register an on-click handler in JavaScript. And then we have our normal app code, so you can put your Google Tag Manager stuff and anything else that's inline. And that way, so now this script is also blocked as we want. And if the attacker was to inject any just like inline JavaScript, that would also be blocked. So we are now protected from cross-site scripting using CSP. Like I said, there are some ways to enable inline JavaScript. I guess there's 3 different ways. So what if you can't move all of your JavaScript? One way is you can take the hash of the script and I'll put the SHA-256 of it into your policy. So if you had something like this, script normal app code, you would take the hash of this, SHA-256, there's plenty of those calculators online, you would take that, and then as part of your policy, under script source, you would say SHA-256, and then whatever that hash is. And so when the browser encounters some inline JavaScript, it's going to see if it's part of the policy. If there's that SHA-256 and the hashes match, it is allowed to run. And so this can be very useful, for example, if you're a larger organization, and maybe you have thousands of pages that all have the same JavaScript snippets, you can just take the hash of it, include it in your policy, and you don't have to move all 1,000 lines. Another way is using nonces. So these are, a nonce is just a token, like hopefully a cryptographically random token. And so what's going to happen is if you have a bunch of different script tags, you can say script nonce is equal to some token, hopefully a long unguessable token. And let's just say ABC123. I mean, it should be random. As we can see here, script nonce equals ABC123. This code will be executed as long as that nonce also belongs or also exist within the policy that is returned for that document. So if you have nonce, ABC123, the script would be allowed to execute. But obviously it needs to be random every time. It needs to be cryptographically random, unguessable. Otherwise, an attacker can just inject a nonce that'll, is guessable, and then it bypasses the CSP protections. The last thing you can do is also a bad thing to do. You can allow unsafe inline, and this will disable the CSP protections and allow inline JavaScript, which kind of negates the policy. There are some other reasons to use CSP besides just an XSS protections, and so maybe you'd use it in that case, or maybe you're rolling out, sure, but just keep in mind that the primary purpose of CSP is to protect against cross-site scripting, and when you enable this, you're losing all of those advantages. As I also mentioned, CSP blocks eval. And so eval is just a JavaScript function. It takes a string and executes that string as JavaScript code. Obviously very bad from a security context, so CSP just disables it. You can re-enable it using unsafe eval. Obviously this is not recommended, but sometimes it's necessary if you're using a library that just can't be transitioned yet. But it'll block anything like eval, function strings, set timeout, stuff like that. Cool. So what happens if an XSS is successfully blocked? You'll get a message in the console like this, refuse to execute this inline script because it violated the CSP. And you'll get, this is the policy that was there. If it was supposed to be there, it gives you some useful tools like either add the unsafe inline. You shouldn't do that, but you could add this hash or add a nonce. And then you can have inline execution. But if you block an XSS, this is what happens, and you've protected your website. Ideally, at this point, you would go and fix the underlying issue that caused the XSS, because CSP is just a protection in depth. Really, you should fix XSSs as you find them. So I have two example policies just to kind of put everything together before we move into how to deploy these. But this is a policy on a personal website I own, just giving an example of a smaller website, what a policy might look like. So we have default source self. So if any directives are missing, I allow anything to be loaded. This website's called Conrad.io. Anything can be loaded from Conrad.io. Under script source, I have this report sample. We're going to talk about report-URI a little bit later, but this basically says if there's a violation, send some of that content of the violation so it's easier to find. I allow these specific JavaScript files. So I allow these script files, object sources. I forget what I was doing here, but for some reason I needed it. There's font sources, frame sources, image sources. Hopefully all of this makes sense at this point. We'll talk about report-URI in a second. For a larger production website, so this is the policy that is currently live on GitHub. One thing that's cool about CSP is because it's returned to every browser, you can just see the CSP policy for any website you want. And so here's the one for GitHub I just grabbed today. Default source none, base source self, they allow child sources from here. This is their connect sources, so a lot of different APIs, font sources, form actions, frame sources, image sources. You can see pretty good policy. Nothing looks too insecure. They allow unsafe inline on style sources, which I also do on my production website. It's possible there's some CSS injections and timing attacks, but you can't do everything. But yeah, these are two example policies. So at the end, hopefully you'll have something like this as you're deploying it to your website. Cool. All right. So now we're going to talk about actually building. So you probably saw those policies were very large. So we're going to talk about some ways to speed up building policies. And thankfully, there are tools that pretty much make this process automatic. You don't need to copy out all of your individual script URLs. There's tools that do it for you. We're going to talk about how long it takes and yeah, some features that make deployment much safer, let's say. So the two features that make deploying CSP so much easier are the report-URI directive and report-only mode. So this report-URI directive, this is an example here. You just specify it with your policy. Basically what this is going to do is it's going to tell the browser that anytime a violation occurs, so something is blocked, it is going to send a JSON payload to this endpoint with the details of what was blocked. And this is just so critical because if we think about CSP, your web server is going to send that CSP header to any client that connects, and then it's going to be used within the client's browser. Without report-URI, you would have no idea what's happening in your client's browser. Like maybe it's blocking critical things and the website breaks. You just wouldn't know unless someone opens up a support ticket and reports it to you. But with this report-URI, you can get real-time feedback about how your policy is doing. Another common example is like maybe the marketing department in your organization releases a new marketing script and it wasn't added to the CSP. Because of that, the website's going to break for everyone. But using report-URI, you can get, real-time feedback that something is broken on your website. You get all these JSON payloads, and you can fix the issue as quickly as possible. So we're going to talk about report-URI, and then we're also going to talk about report-only mode in a second. So with that report-URI, like I said, JSON payloads are going to be sent to the URL you specify, and this is what those payloads look like. So this is an example real policy. We can see that the violation occurred on this website, conrad.io. This is the document URI. So if it was a longer path, you'd see the full path. We can see the violated directive. It is a style source, so it is a CSS that was blocked. I had report sample enabled, so I get to see specifically the first 40 characters of what was blocked. Super useful for debugging. We can see script sample. It was a dot something width 100. I just put this in on purpose for a demo. We can see it was on line 8, so we could go to conrad.io on line 8 and you would see the CSS. We also get to see the original policy. We get to see it was in force mode versus report-only mode, which I'll talk about in a little bit. And also the blocked URI just means, it was inline content. It was just some inline CSS. Otherwise, this would show like the full URL of what was blocked. For example, if evil.com was blocked, we would see, that evil.com/malicious.js. So these violation reports are super useful. So once you set up a report-URI, you're going to receive a lot of reports. So you can use generic aggregators like, Splunk or an Elk stack because every client's going to be reporting the same issues. And so, you'll have thousands of the same reports, which is just too much to manually go through. But, you can aggregate them together. It's a fun project. It was one of my first development projects I did back when I was right out of college. You aggregate them together, you can build a little dashboard, and you can see like in real time what issues are occurring with your policy. What's also useful with these reports is they specifically tell you what you need to add to your policy if it was a valid content. For example, this font source here, we can see a bunch of Chrome browsers, 72 Chrome browsers were trying to load use.typekit.net. I think this is from a Chrome extension, but that means if I wanted to allow this, I would need to add under the font source this URI. Another very useful feature for deploying content security policy is content security policy report-only mode. And so what this does is it'll send the report violation payload to the endpoint if something would have been blocked, but then the browser doesn't actually block it. So you can get a lot of protections of CSP without it actually blocking anything, and you can make sure your policy is working correctly before you break something in production. And so combining these two things together, the report-only mode and the report-URIs, you can build a content security policy very quickly using something I call report-driven development. Not a real word, but basically the cycle goes, you can deploy a CSP in report-only mode. You'll collect a whole bunch of these JSON violation payloads using the report-URI, and then you can update your CSP, your policy, based off of these reports. So you can start with a starter template policy, that just doesn't really have anything whitelisted. You deploy in report-only mode, you're going to get a whole bunch of reports that are going to say, example.com was blocked and, your CDN was blocked. Nothing bad's happening because you're in report-only mode, but you collect all these reports. The browser is telling you specifically what you need to add to make your policy more valid. You add these, you redeploy, and you just keep doing the cycle until you don't get that many reports. And you would do this cycle for all of your different environments. So you would hopefully have a development environment, a staging environment, a production environment, and you're just going to go through. So you're going to start with your development environment. Either you're going to work with a developer or you're going to do it yourself, and you're going to deploy it. If they have like a little Node.js server, you're just going to install the header in report-only mode, collect all those reports until you have a good policy. Once you're pretty comfortable with that policy, you can deploy it onto your staging or QA environment. Tweak your policy, going through that cycle of collecting reports, see what's missing, add it to the policy. Do that in staging QA, and then once you feel confident with that, you can deploy it to production and do the same thing all over again. Again, it's report-only mode, so nothing should break. You can just tune out your policy. Once you're very confident that it works in all three environments, you can go into enforce mode on development. So, if you have your local Node.js instance, put it in block mode, make sure everything's working correctly. Once you feel good about that, go into enforce mode on staging/QA. Make sure that's working correctly, and at the very end, you can go into enforce mode on production, and you have, your full XSS protections, and you can feel pretty confident that if it worked in report-only mode on production, it'll work in enforce mode in production. How long does it take to do that cycle? Again, it's going to be very specific to all the organizations and the website types. It can take anywhere from a day to many months to /impossible, depending on the app. When I deploy it like locally on my websites before, like when I was new to CSP, it took about a day to do on a small web application. Some of the enterprises I work with, if it's a large website and you have many thousands of pages and your development cycle is a little bit slower, not that that's a bad thing, but like if you have to file a ticket to change an HTTP header and there's a change management process, which I'm sure that it's there for a good reason, but if there is there and it takes a week to make every single change, it's going to take a while. Another big factor is how much inline JavaScript you have. Like I said, you need to move all that inline JavaScript into its own files because you don't want to have any inline JavaScript within your application. And depending on how big your app is and how it was built, that can take a long time. But thankfully, a lot of websites that are built like nowadays, they use frameworks such as React and Angular. Thankfully, those are usually pretty fast because they're built with CSP in mind. And so, they can get started pretty quickly, but, it's just going to depend. So anywhere from days to many months / impossible. Cool. And the final section, this is just some of the other stuff that didn't really fit in any other place. We're going to talk about some other CSP protections, misconfigurations, resources, and tools. So CSP was pretty popular, and part of that, a lot of other security features kind of got smuggled into CSP, for better or worse. And so these are some of those security features. So you would include these as directives in your CSP policy, even though they're not really related to XSS. The first one is upgrade insecure request. So you can, if you have like links that go to HTTP, this will automatically convert them to HTTPS. This can be useful for one, actually doing that conversion, but two, you can use it with report-URI to actually find all those places where you have HTTP content. We know we shouldn't be using HTTP anymore. We should be using HTTPS everywhere. So this can be a very useful directive for doing that. There's also a similar HTTP header called xframe options, another security header. This is for click tracking protections. You can use XFO or you can use CSP. CSP actually has a little bit, it's more granular about the protections that it enables, and you can specify origins, which XFO doesn't have the best support for. So if you want a more dynamic XFO protection, frame answers works. There's another thing called sandboxing. So you can, within an iframe, you can specify a bunch of sandbox attributes, and they really lock down a page. Like you can block alerts, forms, downloads, all that sort of stuff. You can apply those protections to your web page too, if you wanted, through CSP. There's also trusted types. This is a way to block some of the DOM API syncs. So there are things like inner HTML, which are very sensitive APIs within your DOM, within the JavaScript running on your page. And you don't want to, if you don't want to allow them, you can say you must use a trusted type, which basically means you have to like mark a content as allowed before it's allowed to be fed into an inner HTML. It's experimental, but it's exciting work. And there's also the navigate too. It's common, like if I do a CTF challenge, or it's common to redirect the window location to somewhere malicious. You can use this for spoofing or leaking cookies and stuff like that. You can block it using a CSP. But it's also, I think, in the experimental page. Cool. Some common questions I get and misconfigurations that I see. People ask if you can deploy multiple CSP headers. You can. Each one is going to be treated like its own header. Like its own CSP policy. Things can get pretty confusing pretty fast, so I don't really recommend it unless you have a very unique or interesting reason. But for the most part, I think one policy is confusing enough. Just stick to one policy unless you have a very valid reason. Another common issue I see is people sometimes return the CSP header on their API server, not the server that is returning the HTML. You want to have that CSP header needs to be included on like the base document, like the content or the web request that returns the HTML. Another very common misconfiguration is people using unsafe inline. We've already talked about this, but this negates a lot of the benefits of using CSP. Really you want to get to a state where you're not using unsafe inline. Another common misconfiguration is not including default source, object source, and base URI. All of these, if default source should either be self or none. If you can do none, obviously that's the best. Object source, if it can, should be none. And base source, if you can, it should be none. These are all very security sensitive. Same with script source, but almost everyone has a script source. But all of these, sometimes these are forgotten, and these should either be none or self, but ideally none if you can do it. On sensitive directive, script source, object source, base URI, if you can, you want to use the full path to the resource. If you're using a CSP tool, like a CSP manager, which we'll talk about a little bit later, they'll do this stuff for you, both of these things for you. They'll actually help you with all of these. They'll tell you if you're doing something wrong. These are, if you're not using a CSP manager, some advice to keep in mind. But if you're using a script source, you don't want to include just a generic CDN, like cdn.example.com. You want to do cdn.example.com/jquery.js. You want to include that full file path because for the most part, CDNs allow a lot of different content. And there's a common CDN, for example, that allows you to host your GitHub project for free. So as an attacker, if you see a CDN and it allows any content on a CDN and you find an XSS in a website, you can just upload your malicious JavaScript to that CDN and then include that script tag as part of your XSS, and you can easily bypass CSP. So for the sensitive directives, script source, object source, base URI, stuff like that, you want to make sure you include the full path. Again, if you're using a CSP tool, it's going to help and give you these recommendations for, just automatically. Another thing is not using report sample on script source and style source. Report sample, again, it includes the first 40 characters of whatever was violated. This makes debugging report-URI just so much easier because you can see specifically what was blocked, and so you have like the line number, what was blocked, and it's just very easy to fix inline resources. Other ways to deploy CSP. So CSP v3, this is the most modern version of CSP. Not every browser supports it, but it includes this thing called unsaved dynamic. And this is like a new propagating trust model of deploying CSP. It's not used too commonly. I think only really Google uses it. But it's a new idea where you would have like a loader script, and that'll you whitelist the loader script using a nonce, and then anything loaded in that loader script is allowed. It's like this propagating trust. It's an idea. I'm just including it for the sake of wholeness. If you want to check it out, you can go cspwithgoogle.com. There's online validators that'll just kind of check and make sure everything's okay. There's one by Google called CSP Evaluator. You just go and either drop it your CSP, or you can give it a URL, and it'll check and make sure what you're including is a valid CSP and you're doing the secure defaults. There's also another one on Casper. That's my website, and it'll do a very similar thing. You just plug in your URL. And it'll tell you if you're including unsafe inline, or you're missing full paths, stuff like that. If you're missing a sensitive directive, or also if your CSP is for some reason corrupted, then it'll also not render, and it'll tell you where the error is. So that's how you can validate a policy. There are also automatic policy generators. So these are browser extensions that'll generate a starter policy for you. Like I said, there's that report-driven development where you have a report-URI, and the report-URI, the browser is going to send those report violations and it's tell you specifically what's missing. You can use those to automatically generate a CSP policy for you. So there's two of them. There's one built by Casper again. There's another one by Laboratory. I think this was by April King. She used to work at Mozilla. But both these work if you just Google CSP generator, Chrome or Firefox, they pop up. And like I said, they just automatically generate a policy for you. If you're new to CSP, or even if you're not new to CSP, I just highly recommend using a tool like this to just generate a policy. It'll generate a full policy for you within minutes, and then you can use that as your baseline and continue growing. In terms of report-URIs, like I said, you're going to have all these violation reports. You need some tool to classify them, group them, monitor them, and eventually set up alerts on them. There are tools that do it for you. Again, Casper, this is the tools I built for the last 4 years. This is a report aggregator. So it's going to take all those reports, anywhere from thousands to millions. It's going to group them together and give you advice on how to tune your policy and include them. It's also going to do some things like classification. Like, for example, extensions and stuff will inject JavaScript into a page, and it can be frustrating to know if that's part of your page or part of your extension. And so tools like this kind of know how the different browsers report things, and so it'll let you know this is a browser thing. You don't need to do anything about this. And then also alerts. So if something was to break on your website, like the example, marketing adds a new script tag for some new analytics tool, and it wasn't added to the policy. As soon as you start getting reports, you want to alert on a spike and be like, whoa, all of my customers are running into this error. And the sooner you can find that out, the sooner you can fix your website and get back to how things are going. Also, you want to be alerted on suspicious reports. So if it looks like it's an inline XSS, hopefully you want to fix that as soon as possible. CSP is a defense in depth. It's not perfect. If you play CTFs, there's always new and novel ways to bypass CSP. And so if there is a suspicious report, hopefully you can identify it and fix it, fix the underlying issue, and so then you don't have to worry about it anymore. Like I said, there are paid tools you can use, like Casper is one of them. You can also set one up yourself using Splunk or Elk. A little bit of work involved with that, but there are tools. I also said one of my first development projects was setting up one of these internal for a different company. It's also a fun project. You can do it yourself. You just need to set up a endpoint that collects JSON, aggregates them, and a little dashboard or something that can help you build out your policy. In terms of websites that are useful, a couple. There's the official spec. It's a little heavy. I enjoy it, but I'm also very in the weeds with CSP. But you can check it out. This is the spec that browsers use to implement CSP. There's another website called CSP WTF. Sometimes the reports you receive from the report-URI are very confusing. Browsers sometimes do weird things, specifically older browsers. And so this CSP WTF is a collection of things people were confused about and eventually found answers for. So a fun repo for just kind of going through the intricacies of report-URI. My favorite general documentation about CSP is on the Mozilla website. I think they just do a good job. They also have a compatibility table at the bottom showing which browsers support which features. Everything I've covered so far, unless I said it was experimental, is covered by all the browsers. But there's a lot of stuff that only specific browsers support, like the report-to directive and stuff like that. But cool. Hopefully that was clear, and hopefully it was useful. I'll link the slides down below and any of the URLs that I mentioned in the description. But if anything was missing or unclear, feel free to leave a comment. I'll try to get back to you, or you can reach out to support at Casper. I'm happy to help. And I wish you good luck on your CSP journey, and cheers.